Alright guys, so second video of the week, week 6. This is going to be, really guys, the last few videos have just kind of been heavily based off the review stuff. So if you can remember quadratics, if you can remember parabolas, then a lot of this is going to make sense to you, right? It's just changing up some of those exponents, but the rules that apply to the quadratic still applies to our new problems, right? So hopefully we can make those connections. If we're making those connections, this should be a little bit easier. If you're having trouble making those connections, then obviously, we're here to help and everything like that. But, we'll make those connections for you and with you so that you can understand these, right? So, again, we'll start off with this quick review. So, x squared to the third power, right? So basically what I want to make sure that you guys remember is when you raise a power to a power, right? So if I have x to the second and then I have all that raised to the third, what is that really going to be, right? So here I have x squared 3 times. So let's just write that out. A lot of you remember off the top of your head, you're already screaming at me what the answer is, but I'm just going to kind of go through this methodically so that you see why, right? So I have x squared cubed. That means I have x squared 3 times. So x squared times x squared times x squared. And then I know that when I multiply terms of the same base, I just add up the exponents. So 2 plus 2 plus 2 is going to be x to the 6th, right? And like I said, a lot of you were probably screaming that answer. And that's because when I raise a power to a power, there is a shortcut than just doing it the way I just did it, right? When I have x squared to the third, really what I'm doing is saying, okay, that's just x to the 2 times 3, which is equal to x to the 6th. 2 times 3 is x to the 6th. Or 2 times 3 is 6, right? So hopefully you guys remember that. When you raise a power to a power, you're just multiplying those powers. And then if I come over here, and I have the same roots, right? So now we're getting into different roots, right? You guys are just used to seeing square root all the time and not seeing different types of roots. So now we're getting into cube root, fourth root, fifth root, all sorts of things, right? But as long as it's the same root, remember, we can multiply. So when I have square root of 2 times the square root of 8, I can rewrite that as the square root of 2 times 8. And then I can actually do 2 times 8 inside of that. So I have the square root of 16, and we all know the square root of 16 is plus or minus 4. Right? So really simple. When they're separate square roots like that, we can combine and we can simplify, right? But only if they're the same exact roots, right? If I have let's look at this and say I had a cube root here and then a square root over here, I could not combine these. Or if I had a cube root and a fourth root, I could not combine these, right? They've got to be the same exact root. If they're both the third root, then I can combine them the way I just did, right? So if you guys are comfortable with those rules, we're going to be just fine throughout the rest of this worksheet, right? So number 1, very simple. We're not going to worry too much about solving it completely because it probably won't give us a perfect answer. So let's just worry about the rule that we just talked about, a power to a power, right? So x squared to the third power, we just multiplied exponents. That's exactly what we're going to do here, right? It's exactly what we're going to do here. I'm sorry, I just wrote that. So when I have 12 squared to the 1/4 power, really all I'm going to do is 12 to the second power times 1/4, right? So I'm going to make that a fraction. So really I have 12 to the 2/1 times 1/4. If I multiply those across, I'm going to get 12 to the 2/4. And I can simplify that to say I have 12 to the 1/2. Which if I really wanted to, I can simplify more and say that's the square root of 12. Remember, because 1 is exponent, 2 is radical, or 2 is root. So I have 12 to the first power, which is just 12, and then the square root under it. Right, so either of these is acceptable for me. But you see what we're doing here, right? Pretty simple. We just take this, multiply by this, that becomes our new exponent. Big deal, right? And then we can simplify 2/4 all day to 1/2. Pretty simple, pretty simple. Right, let's move on. So then number 2. This is getting a little bit more complicated, right? But if we take it step by step, we're going to be just fine. Last week, you guys learned what this means. Sorry, that's a really bad circle. this means, this negative in the exponent, right? It just means I'm going to take the reciprocal of whatever is being taken to that exponent, right? So whatever's in that parentheses is going to get flipped. Simple as that, right? So I can get rid of that negative as long as I come in here and I flip what is in there. So I have 6 to the third over 9 to the third, and those 3's are just terrible. It's okay, I'll rewrite them here in a second. So I just flip those over. So I have 6 to the third over 9 to the third instead of 9 to the third over x to the third, right? And then that negative goes away, it goes poof. Okay, another thing that you guys might remember, which I probably should have put in the review, but that's okay. You guys should remember this. When I have something raised to the same power in the numerator and the denominator, when I have a 3 here and a 3 here as exponents, I can take out that exponent and raise it to that entire fraction. So what I'm going to do here is I'm going to say I have 6 over 9 to the third. Right? I can just take that these 3's away and put them on the outside of that fraction. So I have 6 over 9 to the third, but then I still have all of that raised to the 1/3. And now it just becomes layers of exponents, what we've been talking about, right? It's exactly what we've been talking about. So then I can say, okay, well, I just really have 6 over 9 to the third power times 1/3. And again, I'm going to come here and rewrite this as a fraction just to make it easier on myself. 3 over 1. And then I can multiply across so that really what I have here is 6 over 9 to the 3 over 3 power. And I can simplify that down to it just being equal to 6 over 9 to the first power, which basically means I just have 6 over 9 as my answer. Right, now that was some real layers there, right? We had to do quite a bit for that. Let's just recap it really quick, right? So first we want to get rid of that negative exponent. We want to get rid of that negative. So what do? We flipped it, right? So flip. We flip the inside. So instead of 9 to the third over 6 to the third, we have 6 over third over 9 to the third. And then we took those cubes here and just made the entire fraction cubed instead. So we just took the fraction 6 over 9 and made the whole fraction cubed instead of having its individual parts cubed. Then we did what we just talked about. We take that power to a power, so we just multiply, and I get 3 over 3 is my power, 3 over 3 is 1, which means I just have 6 over 9 as my answer. Oh, and then, silly me, we can simplify that again. 6 over 9 is really 2 over 3. Oops, that's a marker. Is really 2 over 3. So it's even better. Haha. Always simplify. Right, so 2 over 3 is our real answer, not 6 over 9. Although I would have accepted 6 over 9. Okay, so pretty simple. It'll just become a little bit more layered as we go, but no big deal there. Okay, number 3. Again, we got to make sure, first things first, that these roots are the same roots. So I have a 4th root and a 4th root. So that's all, no big deal. I can combine as I wish. Sorry, 4th root and a 4th root. So I can combine all as I wish, right? So let's get rid of that, and let's do it. So instead of having them separate here, I can have a 4th root of 8 times 8. I know that 8 times 8 is 64. And although that might be acceptable for a lot of teachers right now and everything like that, we can in fact factor tree this. So let's go ahead and factor tree it, right? So I'm going to factor it out to 8 and 8 first. And then I have 4 and 2. And then I have 2 and 2. And then again over here I have 4 and 2. And then I have 2 and 2. And then I'm going to go ahead and circle all my prime factors. And you might remember this from simplifying just square roots, right? But now we have a 4th root. So now instead of pairing up just 2 things, I need to pair up 4 things. So all 4 of these are going to get paired, and I'm going to be able to simplify that down to a 2 on the outside. So I have 4 2's there, so that will come out. And then I have 2 2's left over. 2 times 2 is 4. So that's going to be my final answer. Okay, guys, don't worry too much about this. I just wanted to show that. I wanted to spend a second on it. Since it's 4th root, I need 4 pairs. Not 4 pairs, 4 matching, right? So 1, 2, 3, 4. That will bring it to the outside of that 4th root. And then whatever's left remains on the inside. 2 times 2 is 4. That remains on the inside. Okay, again, do not worry too much about that if it doesn't make too much sense. Okay, you can simplify using other means, and that'll be fine. Right? Coming down to number 4. Again, it's the same thing. Same thing here. Right? Looks a little bit more scary, but rest assured, you're going to be just fine. Right? So here, they're all to the 4th root, so that means I can combine all of them. Right? No worries, I can combine everything. So let's do that. So on top, I'll have 4th root of 2 times 32. And I'll just bring this along just to make sure I don't forget about it. 2 times 32 is 64. So it's actually going to end up being like the one we just did, but that's okay. So we have a 4th root of 64 over 4th root of 4. Now the same thing applies here, guys. I can use division as long as these roots are the same, which we already said they were. I can use division on the inside of it. So I'm going to bring this down here, and I'm going to have the 4th root. And I'm going to have to make this one tall because I'm going to have 64 over 4 in here. (64) divided by 4, guys, is going to be 20, not 20. I'm a fool. 16. So the 4th root of 16. And then, again, guys, use your calculators here, but the 4th root of 16 is just 2. So that will do it right there, right? So if ever they are the same root, you can do all those operations inside of them, right? You can do all those operations inside of them. So down to number 5. This one's going to be a little bit of a doozy here, right? So this one is actually, I'm going to need some real full attention here. And again, like I mentioned before in some of these videos, if you need help with this, right, this is a completely somewhat new concept. So if you're having a little bit of trouble with this, feel free to ask us for help. We'll be more than happy to clear this up with you. So just kind of follow along here, pay close attention, see if you can get to it, right? So here, in order for you to combine exponents, we need the same base. For example, if I had x squared times y to the 4th, I can't combine those. They don't have the same base. So my answer is literally x squared y to the 4th, right? I can't combine them. This doesn't work for me. Same thing goes for numbers. When I have 27 as a base and 9 as a base, I cannot combine them. They have to stay separate. So we've got to get kind of clever sometimes and change the base of some things. Now you can't do that quite as easy with variables like over here, right? You just can't. But, and I'm going to erase that as I talk, but with numbers, it is going to be doable, right? It's more than, you're more than capable of doing that. Now, it takes a little bit of just kind of seeing things in a different way. It's conceptual, takes being a little bit clever with it. But let's see if we can do that. So I like this base 3. And a lot of times when you're having to change bases of things, the base that you see is going to be there. Not until way later you're going to see different bases, stuff like that. You'll have to get a little bit more clever. But here, usually they're going to show you what base you need. So I'm going to take base 3. Right? I need all these bases to be 3 in some way. Right? So this one's already a 3. I need to get this one to be a 3 and this one to be a 3. So I got to think a little bit. Okay, 27 is 3 to the what, right? Is 3 to the what? That's not a 0. That's more of like a missing box, right? So 27 equals 3 to the what? Well, a lot of you might know that 3 to the 3rd is 27. So I can rewrite 27 as 3 to the 3rd. That's perfectly acceptable. Same goes for 9. What is 9 equal to? 3 to the what? Well, I know it's 3 squared. That one should be fairly easy for everybody. And then the 3 down there is just already equal to 3, so I'm not worried about it. How will this work? There we go. Okay. So now that I know what I can rewrite these as, I'm going to do exactly that in blue here. That's fine. So I'm going to do exactly that with this problem up here. So instead of writing 27, I'm going to write 3 to the third. And that still does not get rid of the outside exponent that I have, 3 over 8. That doesn't just poof, it's gone, right? It's got to stay there. Oops. It's got to stay there. So I still have that 3 to the 8 on the outside. Same thing here. I'm going to multiply it by 9, which I'm going to, again, rewrite as what I have in blue up here, 3 squared. But same drill here. That exponent does not go away. It's an 8. And the bottom is going to stay the exact same as it was because I didn't have to change anything. Now I can start manipulating this, right? Now this turns into what we were just talking about. Now I can combine these two exponents. An exponent raised to an exponent is just multiplication, right? And this one too, I can combine these exponents by multiplying. So that's exactly what I'm going to write over here. So let me erase some of this so it doesn't look so bad. So I have that equal to 3 times that 3 in the numerator is going to be 3 to the 9 over 8 times 3 to the 8 over 8, because 2 times 4, right? Over 3 to the 1 over 8 still. And yes, guys, this will simplify down to just 3 to the first, which is just 3. But for this sake, I'm going to continue to leave it as that fraction so that you see what I'm trying to get across here. So as I continued working this problem, I've got to start simplifying things. So now these are the same base. Now I've got base 3, base 3, base 3. So now I can start combining these exponents as I want, right? So when I multiply terms, my exponents will add together. So the top will simplify down to 3 to the 17 over 8, right? Because 9 plus 8 is 17. And the denominator stays the same, so I have 17 over 8 divided by 3 to the 1/8. Then when I divide exponents of the same term, I'm really just subtracting. So I have 17 minus 1. That's going to give me 3 to the 16 over 8. 16 over 8 is just 2. And 3 squared is just 9. And there you have it, right? So just a quick little recap of that. Let's make this visible to everything. So I got to rewrite this 27 and this 9 so that I can start combining later, right? 27 is 3 to the third, 9 is 3 squared. So I rewrite this whole equation with those rewrites. Instead of 27, I write 3 cubed. Instead of 9, I write 3 squared. I combine these exponents by multiplying them. 3 times 3 is 9. 2 times 4 is 8. And then what I can do here, since I'm multiplying the same term, the exponents will be adding together. So 9 plus 8 is 17. And the denominator stays the same, 8. And then when I divide terms of the same base, the exponents will be subtracting. So 17 minus 1 is 16. And the rest is really easy. 16 over 8 is 2. 3 squared is 9. And there you go. Right, so hopefully that wasn't too crazy. This is something, guys, that would require some time to teach and to make understood to you guys. Unfortunately, we don't have that kind of interaction anymore. So, again, don't expect to just completely understand this on the first run through. Ask us for help, right? We're all here via email or Zoom or anything like that. So hopefully you guys are having the time of your lives with this quarantine. But yeah, have a good one.